This.
itself at the starting.
Okay.
Okay. So this is the step we need to follow if we format by mistake two, three
Yes.
times. Then,
Yeah, yeah.
okay, sir. Sir, in real time, let us suppose if my VM got corrupted and image is already there with the sysops. Can we ask them to do it?
Destroy the image. That's it.
Just we can ask yes in the in this. Can you push the image in this machine like that?
Yes, sir.
Okay, sir. Got it. Thank you.
VMs are not starting. Data nodes are not starting. Into format of
Please unshare our
name node. No, I didn't say sir. Name node multiple times. Please follow the Let me share my screen. Okay. Okay. Yeah, you can do it.
Thank you, sir.
Okay, guys, can you see my screen? Okay. Please run below commands if the data nodes are not starting due to format of name node multiple times. Loading up my file. Okay. Is this line fine? Okay. Okay, I'm just putting this in red color so that okay. Okay. I'll upload this document there first. Okay, done. Because okay, I'm seeing this okay. Even in previous batches also I've seen this one, but however, I added these two lines. Okay. Fine, guys. Okay, so I guess okay, we wasted 7 minutes today. Okay, we'll start our regular class. Okay, any questions from previous session, guys? Any questions from previous session?
Yeah, I got one question.
Yes, sir.
So for the balancing process, we have the interval where it checks and we balances, right? But usually, as an admin, is there a place where we check that status, like how
Okay.
it is
So
balanced?
first of all, okay, balancing process is an automatic process. It is not a manual process. Okay, it's an automatic process initiated by name node, and okay, you can see the status in the name node log itself. First thing. Second thing, okay, if you want to enable manual balancing, okay, so then you need to run the STFS balancer command. Okay, when you run STFS balancer command, and uh, if you route your output that command output to a file, okay, automatically you will see the uh, balancer output. I mean, okay, the status okay in that file. Got it?
Okay, okay.
Yeah. So it is a STFS balancer output command. It will be keep on printing the status in the screen actually. Okay, if you route this to a file, okay, you can see in the file. Got it?
Okay, thanks.
Yeah.
And one more question,
Yes, sir.
and also using HDFS, we were able to actually access not only HDFS file system but also local file system, and there are multiple
Yes.
other things we could be
Yes,
able to
yes.
access.
Yes.
So we have seen the read options. So as we are seeing the read options, we can also do the read and write options as well, right?
What do you mean of write
For
option? Okay. So
like
writing.
let's say we can be able to manage the OS level file from the from the HDFS as well. The manage in the sense like delete or anything else you want.
Delete, okay, but you cannot modify.
Okay, okay.
Got it?
Yeah, because VI does not work probably.
Exactly. Okay, so you can't modify an existing file on HDFS, but okay, you can upload a file to HDFS. You can download from HDFS. You can delete the file from HDFS. You can copy a file. Okay, you can move a file. You can do all operations, but you cannot modify the file. Got it?
Got it. Thank you. Thank you.
So any other questions? Any other questions, guys? Okay. If no questions, okay, we'll start with the processing layer, which is very, very important, guys. Which is very, very important. And please try to understand. And you don't miss even one class also in processing layer. If you miss, okay, you'll not understand what is happening in the next class. Seriously, I'm telling you. Okay. Okay. So initially, when we start the storage layer, okay, we started with the problem statement, right? So how did we start the storage layer? So we understood, okay, what is disk, okay, and okay, so what are the internals of the disk? Then okay, what are the issues the industry is facing with the current disk technology? What in case, okay, if my data is growing, okay, I can't fit okay, my data, all my data into single disk, okay. So okay, I want to replace my disk, okay. So we understood what are the different problems with the disk, existing disk, and okay, how to overcome that in distributed file system or using distributed file system we have seen. Okay. In the same way, okay, let us understand, okay, what are the challenges that they used to face, okay, with the help of, I mean, in the processing layer also, in the processing level also. Okay. So normally in 2003, 2000, I mean, okay, 2001, 2002, 2003, that time, okay. So you were having, okay, mostly Pentium 4 machines. Okay. Pentium 4 machines are, okay, that time only for 2 Neo. Okay. So these were the processors, okay, Pentium 4, okay, processor, or Core 2 processor. Okay. So these were the processor available at that. Okay. So normally, okay, what is a core, guys? What is a core? What is a core? Normally, okay, what is a core?
Can we say CPU?
Okay, so Pentium 4, Core 2 are the processors. So any processor will have some cores actually. So we'll have some number of cores. Okay, so Pentium 4 means it is a single core, only one core you will have. Core 2 means it will have two cores. Okay, so this is the one core, two core. Okay, what is this core now? It's a processing unit. Okay, so very simple, guys. Now you open a calculator and you are doing, okay, 2 into 3 equal to 6. You got the 6. Okay, you got a result of 6. Okay, who is giving you the result of 6? Who is giving you the result of 6? Okay, you are opening one Excel sheet. Okay, and you are typing something and saving it. Who is saving this Excel sheet to your disk? Or you are opening a PDF. Who is opening this PDF for you? Huh? Laptop. Anything, any operation you perform should be done by processor or CPU. Okay, sorry, it's not CPU. That should be done by a core. Okay, so think that, guys. Okay, so now, okay, I have one core. Okay, so how much work, okay, one core can do? See here, okay, so we have something called, okay, multitasking and all, right? What is this multitasking? What is this multitasking, guys?
more than one thing we are opening
Uh,
at a time.
yeah, exactly. Okay, so suppose okay now if I ask okay to do okay calculation this one, and at the same time if I open a file, okay, so two tasks can be done by two tasks done can be done parallelly by a core actually. Understood? Two tasks can be done by a core parallelly. Okay, that is called multiple task. Okay, multitasking means okay, it can do multiple tasks, guys. It can do multiple tasks. Okay, I'll give you one simple example, guys. Okay, so right click on this one. Okay, so here, okay, just type okay task manager. Task manager. Okay. So now, okay, if you see the task manager here, okay, processes. Okay, how many processes we have here? How many process? How many apps? Okay, I opened. Okay, apps are processed. I opened here. 10 apps I opened. Okay, I opened calculator 2 times. Okay, calculator. Okay, I opened Chrome. I opened okay Excel. I opened MT Putty. Okay, so I opened Notepad plus plus. Okay, I opened VirtualBox Manager. Okay, so Zoom. Okay, so these many things I opened. These many things I opened. Apart from this one, okay, there are some background process. What are these background process, guys? What are these background process?
Used by
These are the background process which helps you to run your OS. Okay. If you close all these background process, okay, will your OS run? Huh?
No, it will shut down.
Yeah. So it means okay, if all these 149 background processes are closed, it means okay, your OS will be shut down. Okay. So your OS is running means okay, that is running because of this background process. Okay. Now tell me, okay, 148 background process we have. Yes or no? I have 148 background process. Okay. Who will be running this background process? Any process should be run by a core. Okay. But now the question is that okay, how many cores? Okay, how many cores will be used? Okay, to run this background process? Huh? How many background process can be run by a single core?
I think 220 to 40 by using one core.
Only one process by one core.
One core, sir. One core. Okay. Normally, how many process can be handled by single core is purely depends on its speed, guys. Okay. How many process can be how many process can be executed parallelly? Okay, is purely depending on the speed of your core. Understand the performance of your code. Okay, so speed of your code. Okay, so now how do you check what is the speed of the core? How do you check what is the speed of a core? Okay, so obviously, okay, you open this one. Okay, task manager only. Okay, open task manager. So here you have performance. Okay, so click on CPU. Okay, so what is the speed of my CPU? What is the speed of my CPU? 2.9 gigahertz. Okay, so now let's say mine is 2.9 gigahertz. Okay. 2.9 gigahertz speed processor is able to handle 200 processes at a time. Okay, 200 processes at a time. What about okay 1.5 gigahertz processor? It can handle half of the speed, right? Half of the number of processes. Yes or no? Will you agree with me?
Yes.
Maybe with less speed processor may handle less number of processes. Yes or no? Sir, very simple, sir. Okay. Okay. You are giving okay 10 works to a junior, okay, a fresher who joined just now. You are giving 10 works to a 10 years experience guy. Okay. Who will do better? normally. He's a fresher, he doesn't know anything. Yeah, okay. So he has to do slowly. Yes or no? Okay. But okay, the experienced guy, he knows everything. Okay, so he can do his work fast. Correct or not? Okay. So in the same way, so initially when we see, okay, so initially what they have done, okay. So initially, in a year, okay, 2000 and all, okay, so they got a core, okay, with a speed of, okay, 500 megahertz. Think like this, okay. So 100 megahertz. So with the help of this 500 megahertz, okay, I can do, okay, 10 processes at a time. Okay. Otherwise, okay, shall we relate this with a real life example, guys? Real life example. Okay. So what is real life example? Let us take IRCTC website. What is this IRCTC website?
Train
What you will do using this IRCTC website?
Train
You will
ticket.
book the tickets actually. Yes or no? Okay.
Yes, sir.
So think that okay. Now, okay, if the IRCTC application is hosted on a Pentium 4 machine, okay, and okay, if that has only one core and it can execute with a speed of, okay, 500 megahertz. So in a minute, okay, number of tickets per minute. Number of tickets per minute, okay. So how many tickets it can execute? It can create. Huh? How many tickets it can create?
And create.
It can book, okay, actually. See, it means, okay, if IRCTC website is hosted on Pentium 4 machine, which has only one core of a speed 500 megahertz, how many tickets it can book? Think that, okay, 5 tickets. I'm just giving example. Think that in a minute, okay, it can work parallelly and it can book 5 tickets. Okay. So do you think, okay, per minute, if IRCTC website book five tickets, how many tickets will be booked, okay, in a day in IRCTC? Huh? Many, right? Many, right? Okay, so it means, okay, if I go with this speed, okay, 5 tickets, okay, then, okay, in an hour, 300 tickets, in 24 hours, mostly 7,200 tickets, okay, I can book in a day. That's it. Understood? Okay, so how can I increase this one? 7,200, okay, so average number of tickets per day. As it is in a day. Okay. How many tickets, okay, we can book in a day? Huh? 1.3 million tickets in a day. Understand? Okay. On average, okay, they are giving, okay. So on average, they are saying that, okay, so here 1.3 million tickets. Okay. But okay, with this speed, okay, I'm able to run only 7,200 tickets in a day. But okay, what is our requirement? 1.3 million is 13 lakhs. 13 lakhs. Yes. I achieve 13 lakhs tickets, okay, with this processor, with this speed. Huh? Tell me. No, you cannot do it, okay?
No, we cannot book, yes.
But I want to increase this number of tickets, okay? So what to do?
Processor need to be changed. Means to maybe go to core or based on requirement.
Right? Okay. This is the number of tickets per day, okay, you can book. Okay. But what in case if I use, okay, same Pentium 4, if I'm able to increase the capacity of this 500 megahertz to 1000 megahertz, what will happen, sir? Increasing the speed of the processor. Sir, very simple, sir. Okay. If I run at this speed, okay, I can reach. If I run this with speed, I can reach 5 kilometers. So is this? Okay. If I run this with this speed, I can reach 10 kilometers, right? Double the speed.
Yes, sir.
Sir, no. Huh? So what they started doing, okay, they started increase the capacity of the processor. Okay, with this they are able to run. Okay, okay. So, but even though if they run like this, how many tickets they can book? 14,000. Okay. Now, in the later stages, what they have done? Okay, so for this processor, okay, they thought that okay, this is the maximum. Okay, then okay, what they have done? You got to go to DO. Okay, with this one. Now tell me, how many we can do it? Tell me.
Same only.
Huh? See now, okay, with one core, sir, who is this, sir? Okay, Hanimi Reddy, sir. Lot of my voice is repeating, sir. Disturbing the class. Okay, I have one core with this speed, so I can book 10 tickets per minute. But now I have two cores. If two cores work parallelly with this speed, okay, tell me how many tickets I can book? Okay, you're able to understand. If I have one core with this speed, I can book, okay, 10 tickets. Okay, I have two cores means, okay, I have two people who are working parallelly. Okay, I have two people working parallelly with this speed, then obviously I can book 20 tickets. Sir, no?
Yes, sir.
Yes, sir.
Sir, no. Okay. So now, okay, what they have done, okay, so again, okay, they did, okay, but still, okay, it is not meeting our requirement. My requirement is still high. Okay, what they have done, okay, they made it like, okay, 2000 megahertz. Okay. Now tell me, with this one, how many they can book? With 2000 speed, okay, they can book 20. With 2000 speed, they can book 40. Sir, no. Sir, no, guys. Okay.
Yes, sir.
Yes, sir.
But still, my requirement is not meeting. Yes or no? So then what they have done? Okay, so they have done two cores, 3000 megahertz. Okay. So this is the capacity here. Okay, this is the capacity of core here. Then okay, they slowly brought i3 processor. Okay. What is i3 processor, guys? You have how many cores in i3 processor?
Three.
3 means 3, na? 3 means okay, it is a two processor. Okay, but there is a concept introduced. Okay, hyper threading. This hyper threading, guys. What is hyper threading?
Multiple threads.
If hyper-threading concept is enabled, okay, one core acts like one core will okay total vCPUs or what we call. Okay, so this one equal to no. Okay, no, then it is as it is. Otherwise, this into 2. Okay, but i3 processor is a dual core processor, but they enable hyper-threading. Hyper-threading means like how many vCPUs they'll have. How many vCPUs they'll have? 4 vCPUs. Okay, if they work with this speed, 4 vCPUs, how many tickets they can book? If 2 with this speed, okay, they can book 40 tickets. If 2 with this speed, how many tickets they can book?
80.
80 tickets. Sir, no. It means okay. So in this case, okay, I can book in a day. Okay, so 1,15,000 tickets. Okay, but do you think this is sufficient now? But still, okay, my requirement is nearly how many? Okay, they say okay, online book to SSD portal 20 million. Okay, every day. See, sir, this is our requirement, sir. About 20 million people travel. Okay, so our requirement is 20 million. Okay, 20 million is okay, 2 crore tickets. 2 crores ticket. This is our requirement. Okay? But we are achieving only 1,15,000. We are achieving. Yes or no? 1,50,000 we are achieving. Okay, so what to do? My requirement is still increasing. What to do? Can I go with i5? What is i5 processor? How many cores we have? Okay, so this one also will give you nearly that performance only. Okay. Okay, so with this speed, okay, hyper-threading is enabled. Okay, what you can do, so you can reduce little bit, make it 1.5 only. Okay, so if you have, okay, with hyper-threading, yes, okay, one core is acting like okay, two cores. It means okay, if I have two physical cores, okay, this is my requirement. So now, what is i7? They introduced i7 processor. Okay. What is i7 processor, sir? Okay. Okay, in i5, okay, they did something like this actually. i5, increase the speed to 3. Okay, 3000 megahertz. Now tell me, when it is 2000 megahertz, we are able to book 80. Okay, 3000 means 120 tickets you can book. It means okay, even though if you go with 120 with this speed, okay, you can book maximum 1,72,000. Okay. Now they introduced okay i7. i7 again it is a 4 cores, but okay with threading enabled. Means i7 will have total how many cores?
8
Okay,
cores.
so if you see here, you will have okay. So number of cores, number of logical processors. Understood? See, I have so it is clearly saying that okay, my system is having hyper threading enabled. Okay, I have okay total 6 cores. Okay, with hyper threading enabled, how many logical processors? Okay, no, I have 8 cores. 8 cores. Logical processor number of logical processors 16. It means okay, I have total 16 cores in my laptop. Understood? Okay. So this is what okay, they brought slowly. They brought slowly. Okay, so here okay. So okay, so initially 4 cores and this one, and okay, if they work with this speed, how much they can. Okay. So if hyperthreading is enabled, okay, you need to
చేసినాను ఒకవేళ
take
వాడు
okay,
ఏడుస్తుంటే
not
ఆయన
double,
బాబు
okay,
ఉడకబెట్టిన చూడు
5 units, okay,
స్పూన్ తో
120,
తింటాడని తినిపించదు
5 minutes,
ఏం
okay,
చేస్తున్నాడు
90 bits. It means okay, even if you go with this speed, you can achieve maximum of 2,59.
అవునా కాలుతాంది కదా
Okay. So now your requirement is still more to do. Do you think okay, this is sufficient? Now okay, I'm going with okay, 8 cores, this one. Okay. Again with
ఏం
this speed.
ఏడుస్తున్నాడా
Okay. With this speed. So obviously the
రవ్వ
requirement will
తింటాడా
be
బుజ్జి
60.
చేసిన
Okay.
చేసిన రవ్వ తినిపిస్తా తిని
Okay. Next. But still okay, am I meeting my requirement? Hmm? After i7, what you have? Okay. So after i7, you have okay, let's say this is not i7, Ryzen. So in between we have something called okay, so even 6 cores also we got it. Ryzen 6 cores with readiness, 12 cores okay, with this period. Okay, so if it is 180, okay, so it means 240. But still I'm skill course. Okay, what will be the answer? 320, 480. Then this is the requirement. Okay, 12 core will be like 12,280. 12,280 tickets. Still okay, my requirement is not meeting. Okay, so then okay, they introduced 40 cores. Okay, 40 cores. Okay. This is 23 lakhs tickets. And they introduced 60 cores. Okay. It's equal to 2,400 tickets. 34 lakhs. Okay. After that, they increased this one. Okay. So round, okay. This speed. Okay, sir. You see what is happening here? What is happening here? Okay. Did you understand what I'm trying to do here? So think that okay, I started IRCTC in 2000 year 2000. Okay, 2000. Okay. But do you think in the first year itself, okay, I have so many people who book the tickets? Huh? In the first year itself, do you think okay, IRCTC, how many people were booking initially in IRCTC? Nowadays, okay, mostly even village people also, even they don't know anything, okay, they will ask us, they'll come and ask, okay, hey, can you book a ticket for me in IRCTC? Okay. Initially, when they launched the IRCTC website, okay, there were no much people booking tickets online. Okay, people used to go to railway station and okay, they take the ticket and get into the onboard to train. Okay, this was the process. Okay, but slowly. Okay, so initially I thought that okay, not much people will book the ticket, so I bought a Pentium 4 system with this speed. So this can book okay 7,200 tickets in a day. So that time it is fine. That time it was fine for me. Okay, but later I understood that okay, hey, okay, so more than 10,000 people are okay, trying to book the tickets. So number of people started using IRCTC increased. When they increased, okay, when more people are using okay this IRCTC website, do you think okay this speed of processor is sufficient to book the tickets? Huh? Is it possible to? Is it possible okay this speed okay of processor helps? Or is it possible to book 10,000 tickets okay, with this speed of processor? The maximum capacity of this processor is 7,200 tickets per day. Okay, but I want to book 10,000 tickets in a day. What to do? What to do, guys? See, I have a laptop. Okay, so the laptop can book 7,200 tickets in a day, but okay, my requirement is 10,000 tickets per day. What to do? Can I change my processor, guys? Normally, you can change your hard disk. Yes or no? You can change your keyboard. You can change your screen max. Okay, but is it possible to change your processor? Normally, if you change your processor, it is like okay, you need to change your entire motherboard also. Okay, changing only processor okay, may not be possible always. You got my point, okay? Because okay, if I change the processor, okay, the motherboard also should support, right, to that processor. Otherwise, what is the point of changing the processor? So changing the processor means okay, changing the motherboard. Okay, it means changing entire system only. Okay, so it means okay, when my requirement is growing, this system is unused. Is not useful at all for me. When it is not useful at all, okay, I have to throw that system and okay, buy a new system. Okay, let's say I bought a new system with this capacity. I thought this will be 14,000 tickets. Okay, but now my requirement is increased. I want to book okay 20,000 tickets in a day. Is it possible with this system? It is not possible with this system. Then what I need to do? I need to throw out this system. I need to buy a new system. Okay, with this processor. Okay. See, end of the day, in a laptop or desktop, okay, what is the costly device? Costly part. Their motherboard and processor. These two are the costly ones. Okay, the rest of the things are okay, are very cheap. Okay, these two are the ones. Okay, now I'm changing the processor means okay, I'm changing motherboard also. It means okay, most of my system is getting changed. Okay, so yes, okay, for my 20,000 requirement, okay, I have thrown out this old system and okay, I purchased a new system. Okay, which is able to 20,000 per day tickets per day. But my requirement is still growing. Okay, my requirement is this. Okay, so it means okay, every time what I'm trying to say here, every time when my requirement is changing, okay, I have to replace my old system with a new system. Yes or no? Yes or no? Every time if my requirement is changing, okay, now see, I purchase a system, okay, which can book okay 7 lakhs tickets in a day, but my requirement is increasing, and okay, it is saying that okay, I want to book okay 10 lakhs tickets in a day. Definitely existing system is not sufficient for me. Okay, but I cannot say that okay, hey guys, okay, I can book only these many tickets, okay, you don't book. Okay, I cannot say that to you also. Okay, so people are interested to book the tickets at online, so I have to provide I have to facilitate that to customers. Okay, so to facilitate okay the internet booking, I mean the online booking option to customers, okay, what I need to do? Definitely, if I want to allow all the people to use my service, okay, I mean, I need to change my laptop, or I need to change my server. Okay, so now if I keep on changing my servers, okay, so if you go to market today, and if you want to buy a server, okay, you can get a server with a maximum cost of okay 100. Think that okay, so now okay, so this okay 80 core server, it costs you around okay 15 lakhs. Okay, 100 per service, it will cost you around okay 20 lakhs. Okay, so suppose okay, last year I bought this one, but suddenly my requirement got increased. Okay, only 1 year back okay, I bought the system, but my requirement is increased. So what I need to do? I need to throw out this system. I need to buy a new system. Okay, this 15 lakhs is waste investment for me. Yes or no? Okay, so whenever my requirement is changing, I am throwing out my old hardware. Okay, old hardware, it means old processor and motherboard, and I'm buying a new motherboard and new processor. Yes or no? Okay, so don't you think that okay, throwing out 15 lakhs in 1 year, okay, it's a waste of money. It's a big problem. Huh? Otherwise, okay, if I don't change my system, okay, then I cannot allow my customers to book the tickets. Correct or not? Correct or not, guys?
Yes.
Okay.
Yes, sir.
Yeah.
Usually CPUs are super expensive. I mean, we have a lot of production systems running with 4 CPUs even.
Yes, sir.
In other technology.
Yeah. Okay. So these are okay, very costly actually. Okay. Processors are very costly here. So every time my requirement is changing, I cannot throw my old processors and buy a new processor. It involves a lot of money. Understood? It involves a lot of money, lot of expenses. Okay. So what is the solution for me now? So this was the problem. Okay, I mean people were facing sometime in 2003. Okay, so with this also they faced, right? Initially, as I told you, initially I purchased 20 GB hard disk. Okay, so 20 GB hard disk. Later, okay, I upgraded my hard disk, old hard disk to new hard disk of 100 GB. Then like I upgraded to 250 GB. Then I upgraded to 500 GB. Then I upgraded to 1 TB. Okay, then I upgraded to 1 TB SSD. Okay, then I upgrade to 2 TB SSD. Okay, so it means okay, see, as a single person, okay, from 2003 to okay 2018. Okay, how many times I changed my disk? 7 times I changed. So no, see, I'm single person. Okay, and okay, so except me, nobody else will use my laptop. Okay. Okay, so if I'm alone, okay, and okay, I will not have much data also. I will not download any movies, okay, or anything. Only for my work related stuff. Okay, so I need 2 TB SSD. I changed my hard disk multiple times. Okay, so changing hard disk is somewhat okay, at least okay. So if I want to change them 1 TB SSD to 2 TB SSD, it may cost me okay around okay 15,000, 15K. Okay, but okay, if I want to change the processor from okay 6 cores to 8 cores, it will cost me around okay 50K. Changing process will definitely cost you a lot. Understand? Okay, so what is the solution for this now? My requirement is that okay, I don't want to, whenever my requirement is increasing, okay, I don't want to change my old processor, and okay, I don't want to change a old processor. Okay, first thing. Second thing is that okay, I want to extend my old processor. Okay, is it possible to extend my old processor? Definitely not possible. Okay, so what is the solution? Okay, in the storage layer, what we did actually, we connected multiple hard disk into a single unit. Yes or no? In storage layer, what we did? In storage layer, you connected multiple okay, with the help of a software. With the help of a software, okay, you connected multiple hard disks, 20 GB hard disk. Okay. So this is disk one. Disk one. Okay. So you have disk two. Okay. 20 GB, 100 GB. Okay. Then 250 GB. Okay. So then okay, 1 TB. 1 TB. Okay. So 1 TB. Then okay, 2 TB. Okay. You combine multiple hard disks with the help of some software. You combine multiple hard disks into a single unit. Yes or no? Yes or no, sir? Now, what is the capacity of the storage layer now? Okay, 20 GB plus 20 plus, okay, 100 plus 2 plus 500 plus 1024 plus 2048. Means okay, nearly 3942 GB. 3942 GB capacity. What is the storage layer capacity? Huh? What is my storage layer capacity, guys? Here now, what I did, okay, with the help of some software, okay, I was able to combine multiple disks into one big storage. Okay. Tomorrow my requirement is growing. Am I throwing out my old hard disk or am I still reusing my old hard disk? Huh? Tomorrow my requirement is growing. Maybe I will add one more disk here. Disk 8 I will add. Okay, maybe disk 8 okay, I will add with a capacity of 4 TB. Yes or no? Now this is the new hard disk which we added. Okay, so this will become okay, maybe my entire storage layer may become okay. So 7,000. Understand? Nearly 8,000 DB. Am I throwing in this scenario? Am I throwing my old hardware?
No, sir.
No, right? Okay, so this is what okay, we understood. Okay, with the help of storage layer, okay, what we can do, you can combine multiple physical disks into a logical storage. Logical storage. Okay. Now this is what the concept okay, you have in the storage layer. Okay. Now same concept okay, they can when it comes to a RAM. Okay. So let's say okay, you take this example also. Okay, so you take this example. Okay. Somebody told okay, initially, I mean okay, in the initial days, okay, sir, I have 4 GB RAM, sir. Okay, I want to extend. I have 4 GB, sir. Okay, I want to extend to 16. Okay, so you have 4 GB RAM, 4 GB plus 4 GB. You have total 8 GB RAM. Okay, now you want to make it 16 GB. What you need to do? Do you have multiple slots? Only 2 slots. Yes or no? Huh? You want to extend your RAM to 16 GB. What to do? Sir, what you
Remove
have
the
done,
RAM,
sir?
sir.
You have to extend this port. So now, okay, see, I have only two slots. Okay, slot 1 4 GB, slot 2 4 GB. Altogether, okay, I have 8 GB. Okay, I want to make it to 16 GB. If I want to make it to 16 GB, what I need to do? Okay, I need to remove my. Okay, so maybe 8 GB plus 8 GB I can. Sir, no? Sir, no, guys. Okay. Now, okay, if I put 8 GB, okay, then okay, what is the use of this? I mean, can I still use of 4 GB in this scenario? Huh?
No, sir.
Can you still? No, right? You cannot still use 4 GB. Okay, so these 4G, these two 4 GB slots are waste.
Yes, sir.
Okay, so if you want to extend to your 16 GB, the old 4 GB, 4 GB, two 4 GBs are waste. Okay, you need to remove those two, and you need to replace those two with 8 GB plus 8 GB. So that you will get 16 GB. Okay, so but okay, with the help of this one, okay, so you have, okay, let's say, okay, 4 GB slot you have, slot 1. Okay, you have 4 GB RAM, 4 GB RAM, and you have 4 GB RAM. Now you buy, okay, if you want to extend this one, you buy only 8 GB RAM. Okay, now altogether how much it will become? 16 GB. Okay, you still want to increase, okay, so you buy 8 GB. Still want to increase, okay, you buy one more 8 GB. Okay, so like this, okay, you can keep on increasing your RAM also. Okay, so here, so this is the logical storage, this is for storage, but when it comes to processing, okay, when I say logical processing, normally for processing what you require 4 plus RAM, both required for processing. Yes or no? If you have only core and no RAM, can I process anything? Very simple, guys. Okay, so now, okay, I want to open this PDF, guys. I want to open this PDF. Okay, I have only cores. I don't have RAM. I open this one. Huh? Guys, okay. So I have, okay, I removed completely RAM. Okay, I have cores. Okay, can I open my laptop without RAM?
No, sir.
No,
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 sir.
sir.
Means, okay, I cannot start my laptop without RAM. Okay, okay. Now, okay, let's say I have RAM. Okay, but I don't have cores. Can I start my laptop?
No, sir.
No. Okay, it means, okay, to start your OS or to start running your background services, definitely you require both cores and RAM. Okay, then only you can do. Otherwise, okay, you cannot do anything. If only RAM, you cannot do anything. Only cores, you cannot do anything. Okay, if you want to process, okay, process means, okay, running something. If you want to run something, okay, that something can be your OS also. Understand? That something can be your OS also. If you want to run something, you require both core and RAM. Okay. So now what I will do, okay, so now what I will do, so when it comes to, if I want more and more RAM, okay, more RAM, okay, so I will say logical RAM. Okay, so my logical RAM is combination of, okay, multiple RAM slots. Okay, tomorrow, okay, my RAM is, okay, if I want more and more RAM to process my data, okay, okay, then I will be adding extra chips. Understood? In the same way, logical core.
Sir, sir, RAM itself consists of cores, or it is a separate mechanism? Cores.
Sir. What is this, sir? What is this green chip? Huh?
Yes, sir.
The green chip is a processor. Okay. What are these two boxes? Huh?
I think RAM slots.
Sir, these are dice, sir. These are called as dice. Okay. In each die you have something called, okay, so this is a different color, this is different color. Different color, different color. What are these? Each different color is a one logical processor. It means, okay, so this is a 4-core processor. Okay, it's a 4-core quad-core processor with the 2 dies. Okay, this is die 1, this is die 2. In die 1, okay, I have 2 processors. In die 2, I have 2 processors. Okay, if this processor is enabled with hyper-threading, then okay, it will have a total 8 logical processors. Understood? Understood, sir?
Okay, sir.
Okay, so this is your processor. Okay, you know some processors will have, okay, like this actually. It's a big one, 2, 2, 2, 2, like this. Okay, you will have.
Okay.
Understood? Okay, so this is called as a, okay, process. This is called as a die. In each die, okay, you are putting 2 processors, 2 physical cores. Okay, each core will act like 2 logical cores. Okay, that is the reason. Okay, here, okay, so I have 4 physical cores. Okay, which acts like 8 logical cores. Okay, now, okay, so the processor is, this part is the processor. You understood? Okay, this is the processor part, sir. Understood?
Okay.
This is the processor part. Okay, processor is separate. Okay, see, now see how big is this processor. So here, okay, you have die 1. Okay, maybe die 2. Okay, in the behind, okay, die 3. Okay, inside die 4. Okay, die 5, die 6. Okay, like this. Okay, this processor may have dies inside this one. Inside each die, you will have processor 1, processor 2, processor 3, processor 4, processor 5, 6, 7, 8, 9, 10, 11, 12. Okay, 13, 14. I'm just giving example. Okay, so this is your processor. Okay, then what is your RAM? So this is your RAM chip. Understood? RAM chip. These are all RAM chips. Understood, sir?
Yes, sir.
Okay, this is RAM chip. Okay, this is RAM chip. Okay, this is RAM chip, RAM chip, RAM chip. Okay, understood?
Yes, sir.
Okay, means, okay, here I have 32 chips. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, okay, 25, 26, 27, 28, 29, 30, 31, 32. Okay, so now this is the motherboard which has 16 slots. Yes or no? 16 RAM slots. Okay. Suppose, okay, you want more RAM, what you will do? But normally, okay, how many slots your laptop will have like this, guys? How many slots your laptop will have?
Hardly 2.
Only.
Okay, your laptop will have only 2 slots. 2 slots. Okay, where I can see here, okay, the number of slots. Okay, you can see here. Okay, so see here. Okay, see here. Okay, so how many sockets we have? Complete only single socket. Okay. Okay, so how many RAM slots, right? Okay, see here. How many slots? How many slots I have, guys? How many slots I have?
2.
Only 2 slots. Okay, so now I have total 64 GB means, okay, in each slot how much I put?
32 GB.
32 GB plus 32 GB. Altogether minus 64 GB. Okay, understand, guys?
Yeah.
Understand? Okay, in the same way,
Yeah.
okay, for this server, if I right click on it, if I open task manager, it will show total slots 32. Understood? Total slots 32. Okay, and okay, so in that 32, how many are used? Okay, suppose, okay, in 32, you put, okay, so okay, 8 GB, 8 GB, 8 GB, 4 8 GBs. Then it will say like, okay, 4 of 32 used. Out of 32, only 4 slots are used. Understood? Okay, so RAM and processor, okay, this is processor, this is RAM, sir. Both are different. Understood?
Yes, sir.
RAM and processor both are not same. So now Okay, so for processing, okay, you may require more RAM, more RAM. Even for course also you may require. Okay, so today I have, okay, suppose, okay, now I bought a system here like this, guys. Okay, let's say I have, okay, 12 core processor I bought. Okay, if I think that, okay, I require, okay, more and more, okay, I may buy, okay, instead of throwing out my old 12 cores, okay, I will buy one more 12 core here so that it will become 24 core. Okay. So now I still require, okay, still my requirement is increasing. Okay, instead of, okay, instead of this one, what is it? Instead of throwing out my old cores, okay, what I will do, I will add, okay, so let's say I'll put, okay, this time, okay, I'll put 24 cores. I'll buy 24 core processor. Okay, it means, okay, so you are trying to combine multiple. Okay, so now, okay, I will show you guys. Okay, server. Okay, server 1. Okay, inside a server. Okay, how many slots you have, guys? Number of slots. Okay, first, okay, let us talk about this one. I have server 1. I have server 1. Okay, how many RAM slots? How many RAM slots you will have? Okay, so normally, okay, that, okay, number of cores equal to number of slots actually. Okay, so here, okay, so number of cores. Like this, guys. Okay, number of physical cores. I have a 12 core processor space. Understood? I have a 12 core processor. Okay, so normally if number of physical cores are 12, okay, physical cores are 12. Okay, so normal number of, okay, RAM slots. Number of RAM slots, which is equivalent to number of cores. Normally, sir. Okay. So 12 slots. Okay. Now, okay, RAM in each slot. RAM per slot. Okay, RAM per slots. Okay, let's say in each slot you put 8 GB RAM. 8 GB RAM. Okay, so user slots. Okay, let's say if you use, okay, four slots, what is the total RAM of this machine? Okay, understood. Okay, see, I have total 12 slots. Okay, I have total 12 slots. I'll reduce this one. Okay, I have total 12 slots. Okay, so number of, okay, otherwise, okay, like this only. This is my core. Okay. Total RAM is this. This is the I have total 12 slots. Disk slots. Okay. Normally, how many disk slots you will have? When I say server, you will have by default, okay, total 26 slots you will have. Okay. But, okay, user disk slots. Let's say used only 10 slots. Okay. So, okay, storage per slot. Let's say each disk, okay, in each slot you put 1 TB storage. Okay, what is your total storage?
10 TB.
10 TB. Understood? Okay. Now, this is the capacity of a server. What is the capacity of this server? I have. Tell me, sir. The capacity of this server is total
8 GB RAM and 10 TB storage.
12 cores, 32 GB RAM, 10 TB storage. Okay, 10 TB storage. Okay, this is server 1. Okay, the same way I may have server 2 also. I have server 2. Okay, so okay, first thing, okay, or okay, let's say now I have 12 cores, sir. Okay, if I want more cores, Can I do anything with server 1? I want more cores. Can I do anything? If I want more cores, I have to change the server. There is no other go. Only one blind option is that okay, change the server. Okay, but okay. So you take the RAM. If I want to increase the RAM, what I can do? Huh? How many slots are available, sir?
You can build one more slot.
Instead of 8 GB, we can use
So one option is
16
that if I
GB.
want to increase RAM, okay. Okay, if I want to increase the RAM, okay. See, now you can go with the same size, but okay, you increase number of slots. See here, okay, 12 slots are there, only 4 slots are used, remaining 8 slots are free. Yes or no? Yes or no? I want to increase, okay, I will make it like, okay, 6 slots. Then I can make RAM 40. Even I can increase RAM, even I can make like, okay, so let's say, find I use all 12 slots with 8 GB RAM. Yes or no? 12 slots with 8 GB RAM. Okay, so now my system has become 96 GB. Okay. Now, in this scenario, if I still want to increase, something is there, okay. In this scenario, if I still want to increase, I need to throw my old hard drive.
Yes.
And okay, I can go to the maximum 26 slots. Yes or no? Yes or no, guys? But now, okay, but I still increase. See, here, okay, you have chance to still increase. Here, chance is there to still. Yes or no? Yes or no, guys? Okay. Yeah, if I want to increase this one, I will remove all 8 GBs and I'll put all 16 GBs. What will happen? It will become 192. Okay? Understood. So at times, okay, what will happen? Okay, see, now, okay, if you take my system, okay, see my system, if you see the memory, I have 2 slots. I put okay, 32 GB, 32 GB. So totally it has become 64 GB. Okay. But tomorrow, if I have money, let's say think like this. Okay, if I have money, I want to put okay, I want to remove 232s and okay, I want to put 264s. Will my system support? My system will not support for 264s. It will support okay, max of 32. It means okay, you'll have the limitations also, right? If I have money, I cannot put okay, 64 GB here, right? Maybe my server doesn't support the 64 GB slot single chip. Okay, so max, okay, so here, okay, so max, okay, even if you throw it, okay, you can go like this actually. After this one, okay, reach the maximum capacity of this one. Even okay, here also, reach maximum capacity of this server. You reach maximum capacity of a server. You used all RAM slots, you used all disk slots, okay, you put the maximum RAM in each slot, you put maximum storage in each slot. Okay, so it means, okay, this server is completely full now, or not? Okay. You are utilizing the server at max, okay, but still you need more cores. What to do? You still need more RAM. You still need more storage. What to do? All these days, okay, what we have done? Storage.
Yeah, done.
This is just what we have done for storage. Tell me, guys. What we have done?
We added
The
new
storage is full here. Okay, add one more server 2 here. So now again, okay, it may be the same case. So now this is the same case. Okay. Now, what is my HDFS here? What is my HDFS case here? What is my HDFS? 104 GB, 104 GB. Yes or no? If still this is not sufficient, what I will do? I will buy server 3, maximum capacity. What will happen? This is my HDFS. Yes or no? What is my HDFS? Total HDFS. Okay. So total HDFS is equal to sum of 156 TB. Yes or no? If still this is not sufficient, okay. So what I will do? I'll add one more server. I'll add fourth server. Okay. Again, okay. Maybe this server is a new server which can hold up to 4 TB. Okay. So now the new capacity server which has the capacity of 104 TB. Okay. So now my total HDFS is how much? 60 TB. Okay. See, first what I will do before adding a new server, I will see whether okay I have used this server to the max. First thing. Okay. If I use this server to the max, then only I will buy other server. When I don't have any option to increase the storage part by changing anything, okay, then only I'll go for server 2. Okay, but I have some free slots. Okay, these slots, they'll see whether we can do anything, whether we can increase anything with the existing system. If no, then only they will go for other servers. Okay, so like this, okay, this is the total HDFS. This is total HDFS. Okay. Now, when it comes to cores also, okay, now you have a single server. Total cores are not sufficient. What you will do? You will add server 2. Okay. So this may have 24 cores. Understood? Okay. Now what is my total? What is my total? What is it? Number of cores? So you will say total HDFS is equal to 260 TB. Okay. If you still want, okay, you add up one more server like this. Okay. Now, what are the total cores? How many cores we have now? Okay. 6 cores. If you still feel that okay, so these are not sufficient. These are not sufficient. Okay. Some more cores. Okay. So let's say this server is having okay. This also 24 cores. Okay. This is having 48 cores. Okay. Understood, guys? Okay. It's up to you. Now, okay, if you see here, okay, so how many cores you have on average? I mean, overall. Huh? Overall, how many cores you have, guys? 108 cores. Okay. In the same way, if I go with the multiple servers and okay, RAM slots, okay. So think that okay, this is the RAM okay used here. Okay. Second server also same. Okay. Third server also, it's the same. But fourth server, okay, you increased. Okay, increased like this. So, 12, 16. So, but here, okay. So here, okay, you have gone with maximum of 24. So let's say here, okay, so 32 cores, okay, 32 cores, okay. Used all 32, okay, and maximum, okay, 32 cores, 1 TB RAM. Okay, so now if I see total RAM, what is the total RAM now? Tell me,
So
yes.
Venkat, in short, in Hadoop, like disk, we can add new servers and increase the processing capacity. Yes.
Exactly, sir. Okay. So here, okay, what you are doing, okay, by adding multiple hard disks into a single unit, okay, okay, you are increasing the total capacity of your storage. Yes or no? In the same way, by adding multiple physical cores into a single unit, you are increasing the processing capabilities, processing capacities. Understood? Sir, tomorrow, think like this, okay? Think like this, okay? I have a requirement of, okay, I have a requirement of 20,000 cores, sir. Even though I have money, can I get a 20,000 cores processor in the world?
No, sir.
What is the biggest processor, okay, we have in the world? How many cores that biggest processor is having? That is with China now. World largest processor is 102 cores. Okay, this is the largest processor we have in the world. Okay, but my requirement is 20,000 cores. What to do? If I want to make my total capacity as 20,000 cores, okay, this is the only option. Yes or no? Merge multiple physical cores into a single unit of, okay, logical cores. Yes or no? Okay, like this, okay, you keep on adding this one, okay, server 4, okay, now you add server 20. Finally, if we add, okay, server 20, okay, and okay, server 50, okay, more and more you add, okay, one fine day, your total HDFS may become, okay, so 10,000 TB. Your course may become 20,000 cores, 2,000 cores. Understood? Okay, and your RAM may become, okay, so how much GB? Okay, let's say 10,000 GB RAM. No. It means, okay, yes, okay, stand, sir. Okay, so you see our current cluster, okay, we have around 54,000 cores. Understood? 54,000 cores. Nearly this is, okay, 1 lakh GB of RAM. Okay, so this storage, so 80 petabytes means, okay, 80,000. $80,000. Understood, sir? Understood? So this is our cluster capacity. Do we have any single system with this capacity?
So that is the maximum size for that.
There is no maximum size. It can still grow.
No.
That's what Hadoop is unlimited. Okay. So is there any limit that a number of, okay, servers only this much in Hadoop?
No.
You can go to 25,000 servers. Okay. You can go to 25,000 servers. Okay. Just imagine 25,000 servers, physical cores, 25,000 servers, RAM. Or if you sum 25,000 servers, RAM. If you sum 25,000 physical cores, if you run 25,000 storage from 25,000 servers, just imagine how much it will become. This is the capacity of our current cluster. Okay? It's around 4,000. Not even 4,000, around 2,000 plus.
So it's like a parallel mechanism, sir, right?
Yes, right.
Yeah.
See, when you cannot bring a new system here, okay, you can see here. Okay, what are you doing? Okay, so if you want this kind of a server, can you bring a single server? Okay? See, when you cannot manufacture, okay, server huge capacity, what you will do? Huh? Logically combine multiple into a big server with huge capacity. Okay. Now, when somebody come and ask, okay, what is your total capacity? Okay, I will tell, okay, I have 8,000 TB storage, I have 54,000 cores, okay, I have 1,24,000 GB of RAM. Tell me what do you want? Understood, guys? But now, okay, here, okay, 8,000 TB of storage, 80,000 TB of storage, but is it from one server or multiple servers? Huh?
Multiple.
Multiple servers. Okay, it means, okay, you are combining multiple physical storages into one logical storage. Yes or no? You are combining multiple physical cores into a logical core. Okay, you are combining multiple physical RAM into a logical RAM, a big logical RAM. Understood? You are combining multiple physical storages into a big logical storage. Combining multiple physical cores into a big logical core. Okay, logical processor.
అదే హరికిషోరే
You are combining multiple physical RAMs into
హరికిషోర్ అదే
a huge
7 rows
logical RAM. So logical RAM means, okay, so here, okay, logical storage.
హరికిషోర్ 7 rows దగ్గర అది మెడికల్ షాప్ ఉంది
Storage from
7 పాత కలెక్టర్ ఆఫీస్ ఎదురుగానే
combination of storage
ఓ
from
మా అయిపోయి తెలుసు కదా నీకు ఆసుపత్రి ఇంత ముందు పోయినా
disks
హలో
or
మా
servers. Sir, no.
హలో
What is logical storage?
అమ్మకు తెలుసులే మీ
Combination
హాస్పిటల్
of
హరికి ఆడ కాదు వరాలు ఆడ మందుల షాప్ ఉంటాయి చూడు
multiple servers. It is called
ఏ రోడ్లో మందు షాప్ ఉంటుంది కదా
okay. Then okay, multiple servers. Okay, so what is logical RAM? What is logical RAM? Combination of RAM from multiple servers. Okay, understood, guys? Combination of RAM from multiple servers. Okay, so here this is a logical storage. Okay, logical storage, and okay, logical processing. Under logical processing, when I say logical processing, it is sum of this one plus this one equal to logical processing. Understood, guys? What is logical processing? Sum of cores plus RAM, which is equal to logical processing. So this is logical storage, logical processing. questions?
Sir,
Yes, sir.
user slots
Hmm.
12, 12, right, sir?
Huh?
Okay, sir.
Total slots are 12, user also 12.
Fine.
Okay.
RAM for slot. Okay.
Okay. It supports a maximum storage of maximum RAM of 60 GB per slot. You put maximum. It means okay. If you use all maximums, okay, you got 192 GB of RAM. Okay. You cannot increase beyond this one. Understood? Understood, sir?
Yes, sir.
Okay. So this is the maximum RAM you can put here. Okay. That's the maximum RAM you can put here. Okay, let's say 32 GB. So this is the maximum capacity of the system. Understood? You cannot increase beyond this RAM in this machine. You cannot increase beyond this RAM in this machine. Okay. You cannot increase beyond this RAM in this machine. Even if you have money, okay, this slot will not support a 64 GB. No, it supports max of 32. Okay, you have all 32. You put all 32 GB RAM in all 32 slots. Okay, can you still increase the capacity of this server? You reach maximum capacity.
No, sir, we cannot.
Understood?
Yes, sir.
Okay, see, normally when you reach maximum capacity of a single server, then only you will go for other server. Understood? If I have, okay, see, like this, okay, I want more RAM, sir, okay. I have 12 slots, okay, used only 4 slots, 64 GB. If I want more RAM, okay, buying one more server is better, or okay, adding one more RAM slot is better?
Yes, sir. Adding one more.
Yes, okay, then it will become 96 GB.
Yes, sir.
Okay, till you need increase, okay, you make it 10, okay, till you want to increase, okay, make it 12. After this, you cannot increase. Sir, no.
Yes, sir. Yes.
All 12 are used. You cannot do anything after this one. Okay, it means, okay, normally people will add a server to the cluster, okay, only when they don't have chance to increase any capacity, or when the server reaches the maximum capacity. Understood?
Yes.
Yeah. Understood. Any questions? So what is large scale storage here? Large scale storage means, okay, so the sum of all the disk, okay, here, okay, so 52 TB I have. Is this 52 be single disk or okay, 26 disks? Huh? Tell me, sir. Here, okay, so number of disks, okay, OS disks 2, okay, so let's say 24. These are 24. Okay. Here, every machine will have 2. Okay. Now, this is the capacity. Here, 48 TB means, okay, is it a combination of multiple disks or not? Combination of multiple disks, one server is coming like this. Okay, but still I want more storage. Again, combination of multiple disks from multiple servers. Then it will become 96. Yes or no? See here, when I say 96, is it a combination of, okay, only 2 servers, or okay, 2 servers and multiple disks? Multiple disks. Okay. Yes, okay. You need to visualize. When I'm explaining something, you need to visualize. Then only you can correlate. Okay. See, definitely, the more and more users are using your service. Okay. You take IRCTC. Okay. So, do you think of IRCTC? Okay, one server is sufficient to manage IRCTC? Do you think they are using only one server to manage?
No, sir.
Understood. Okay. So I heard that recently. I heard that okay, so they are migrating this entire IRCTC website to Hadoop. Our Aadhaar card project is on Hadoop. Do you know that? Huh? Our Aadhaar card database. Okay, our Aadhaar card details. All Indian people Aadhaar card details are stored into a Hadoop cluster. Do you know that? That Hadoop cluster is managed by HCL company. Understood? Okay. So definitely, so when data is increasing, okay, one server is not sufficient, the one disk is not sufficient. You may have to go with multiple disks or multiple servers. Okay, and at the same time, okay, if there are more people to access the data, okay, multiple cores are required, and okay, multiple RAM also, okay, multiple cores are required, and okay, so huge size of RAM also required. Okay, understood? Okay, so by combining multiple cores, okay, multiple cores and multiple RAM, you will create a logical processor. Okay, so now when I say logical storage, okay, what is the name you are given for logical storage? What is the name you have given for logical storage? Yes. SDFS, right? What is the name you have given? Okay. In Hadoop, what is the name of logical storage? SDFS.
Yeah.
So, okay, so logical storage name is SDFS in Hadoop. Okay. So, but okay, to run this logical storage, what all required is to run this logical storage, what all required? You need some services, right?
Name node.
What is master service? Okay, what it does? Maintains what it does. It holds metadata. Okay, metadata of logical storage. Name node maintain metadata of logical storage. Yes or no?
Yes, sir.
Will you agree with me, guys? What name node will maintain? Metadata of logical storage. Okay. What are the worker service here?
Data.
Okay. So what data nodes will maintain?
Actual data.
Actual data will be okay. Actual data in logical storage. Actual data of logical storage. Okay. But this actual data will be stored in one disk or okay. Okay. Actual data in the form of blocks. Blocks stored in multiple disks. Sir, now. Agree with me, guys?
Yes, sir.
Okay. If data node service is not running, can we use the hard disk of that machine? See, I have. Okay, see here. Okay, let us take this another. I'll open name node. Okay, name node UI. Okay, name node UI. Okay, so now data nodes. Okay, if one data node is not running, okay, will you have the storage contributed to logical storage?
No, sir.
No.
If H3 and N3 is not running, okay, your logical will not storage will not show this 300 GB. It will show only total 600 GB. Yes or no? Yes or no, guys? Okay, it's okay. But data nodes are the one. Data nodes are the one who will maintain actual data. And okay, so blocks are stored into multiple disks. Okay, and okay, if the data node service is down, okay, that particular server storage cannot be added to logical storage. Yes or no? If data node is down, okay, that particular data node servers storage will not be added to logical storage. Correct or not?
Yes.
If Dn is down, now the respective storage cannot be added to logical storage. Yes or no? Yes or no, sir? Will you agree with these points? Tell me. So maintains the metadata of logical storage. Data is maintain actual data of logical storage. Okay. So how actual data will go in the form of blocks? Blocks are stored into multiple disks of data nodes. Okay. If data node is down, the respective storage in that data node will not be added to logical storage. Understood? Is it fine with you guys? Is it fine with you?
Yes, sir.
Okay. So now, who will send the information to whom that okay, I have this much storage. This is the total storage. This is the user storage. This is the free storage. Who will send this information to whom?
Data node will send
Data node
Each
sent to
data
name.
node will
Data
send
nodes
the
will send to name node.
information to name node. Send that, okay, this is my total capacity. In this is the user capacity. This is the free capacity. Yes or no? Yes or no, guys? Okay.
Yes.
Now, okay, name node will show all together like a single storage. Yes or no? So what name node is doing here? Okay, name node is showing everything like okay. So name node is telling that okay. So this is the name node I opened. Name node is telling that okay. I have total DFS is okay 900 GB. This is what okay. Name node is showing. Correct? Correct or not? So each data node is sending this report to name node. Okay, I have this much. I have this much with me. This much with me. This much with me. Okay. Now name node is collecting all this information and okay, showing us like a single unit. Yes or no? Single capacity. Correct? So this 900 GB capacity is from one node or multiple nodes?
Multiple node.
Multiple nodes. Okay. Again, this 900 GB capacity is one disk or multiple disk?
multiple disks.
Multiple disk. Multiple nodes and multiple disks. Yes or no? Yes or no, guys?
Yes, sir.
Okay. So name node will show like a single capacity. All this together, okay, name node will show like a single capacity. Okay. And but data nodes will send like okay, individual capacity. Okay. And data nodes will tell okay, this is my individual capacity, individual capacity, individual capacity. But name node will show like okay, overall single capacity. Okay. In the same way, when it comes to processing, okay, so it is called as Understood. What is the name of the processing layer? What is the name of the processing layer? Here, this is called as logical. This gives us the name of logical processing is here. Okay. And okay, what is the like? How okay, we have different services. We have different services to maintain the logical processing also. Okay. So when it comes to master service, okay, we have resource manager. Okay. Okay. So here, okay, so display the or no? Huh?
Venkat, where we can get processing capacity for the
Sorry.
master processing capacity, where we can get?
Will tell you, sir. Okay. So here, name node is the master service which maintains metadata of Elastic storage. And okay, what else? What it will do? Display the overall capacity of storage layer. Yes or no? Yes or no, sir? Okay. So in the same way, we have a master service in processing layer which is called as a resource manager, which maintains the metadata of processing layer, physical processing. What do you mean of metadata of physical processing, guys? Okay, then display overall capacity of processing layer. Tell me, okay, what is the metadata of physical processing? Can somebody give me example?
Maybe it should be giving the same status.
What is the metadata of Elastic storage? What is metadata of Elastic storage? So for each file, okay, let's say you have file 1, okay, you have a file 1, how many blocks we have, okay, what is the name of each block, that is metadata, correct or not? Okay, so here, okay, metadata will show like, okay, so what is each file, okay, and okay, what are the blocks under each file, okay, or how much is, okay, how much capacity is used by each file, yes or no? Metadata means, okay, so how, what is the, all the properties about each file, yes or no? So when I say properties, okay, so it is like, okay, what is the file name, what is the, who is the owner, who copied this file, who is the group, okay, what are the permissions, timestamps, okay, then okay, replication factor, then okay, block size, then okay, file size, then okay, block numbers, all this comes under metadata, okay. In the same way, when it comes to resource manager, okay, when I say metadata of logical processing, it will include like, okay, see, when I say cluster, only one person will be using a cluster, or okay, multiple people will be using cluster? Huh?
Multiple.
Multiple people, okay. You know that, okay, we have multiple teams, right? Bangalore team and Hyderabad team, yes or no? Under Bangalore team, okay, you remember this one, guys? Okay, see here, okay, so we have, okay, Bangalore group. Under Bangalore there are 4 people. Hyderabad group, these means 7 people, 3 people. So it means all these 7 people can use the cluster, right? Huh?
Yes, sir.
So it means, okay, so metadata means, okay, who is using how much will be shown here. That is metadata. Understood, sir? Which user is using how much core, how much RAM? That is metadata.
It will be a live report.
Live report. Okay.
Got it.
And then it displays the overall capacity of a processing layer. What do you mean overall capacity? How many cores we have all together from all the servers. Okay. Understood. Okay. And how much RAM we have from all the servers. Here, okay, overall capacity, see here, when I say overall capacity, that overall capacity include name node storage also? Overall, does the overall capacity include name node storage also?
Yes.
No, sir.
Huh? What is STFS?
No, sir, no.
What
No,
is
sir,
STFS?
because it will not use, yes, name node capacity.
STFS means, okay, it's a combination of data node hard disk. Okay, not like a name node hard disk. Understood?
Yes.
HDFS means overall capacity means, okay, it's the sum of all the disks from all data nodes. Understood? Okay. So overall capacity does not include name node storage. Okay, overall capacity equal to sum of from yes or no? Will you agree with me? Overall capacity. So overall capacity does not include name node storage. Overall capacity includes only data node storage, all data node storage. Okay. So here overall capacity to again here sum of all cores and RAM from all. Okay. What is NM here? It is a node manager is a slave service here, guys. Worker service. Understood? Understood, guys? So here, how you have a master service and worker service here. In the same way, in the processing layer also, you have a master service and worker service. Okay. So what it will do? This is a metadata of a classical processing. Okay. So then, okay. So actual utilization of classical processing. Okay, you saying that okay, Venkata is using 10% 20 GB RAM. From where okay, he will use Venkata will use from multiple one or more node managers. Yes or no? Yes or no, guys? Yes, okay. Are you able to follow me or facing difficulty? Yes, I know that okay, processing layer is little bit tricky, but okay, I'm trying to correlate and explaining. Huh? Tell me, guys. Okay, if you have any difficulty, please let me know. I can explain once again. Okay. So here, okay, node manager is a worker service. So here, actual utilization of logical processing. Okay, so here send the individual capacity of processing. Okay, if NM is down, respective processing, respective cores and RAM will not be included in the will not be added to logical processing. Understood, sir? Understood. Suppose now, okay, if this server 3 is down, okay, these cores will not be added, this RAM also will not be added. Okay, then size reduced or not? Okay, if server 3 is down, system will say I have only see, system will say I have only 192 TB of storage. Okay. And it will say I have only 68 physical cores. It will say I have only 1984 GB of RAM. But okay, this is back. It will show more capacity. Understood? If any node manager is down, that machine's cores and RAM will not be part of overall capacity. Understood? If any data node is down, that machine storage is not part of overall capacity of a storage layer. Understood? If any node manager is down, okay, that machine's cores and RAM will not be part of your processing layer. So when I say storage layer, live data nodes, sum of all disks, okay, sum of all storages from live data nodes. Yes or no? What is the storage layer? Equal to sum of all storages from live data nodes. Sir, no? Will you agree with me? No. But it's processing layer. Sum of all cores and RAM from live
Name nodes.
node managers.
Node managers. Node manager does not include name node, yes, Venkat?
Wait, sir, wait. Okay. You understood the concept now? What is storage layer? Sum of all the storages from live data nodes. What is processing layer? Sum of all cores and RAM from live node managers. Yes or no? Any questions now? Any questions now, guys?
Sir, you said name node is not included in HDFS, right?
Of course, yes. In the same way, okay. Resource manager cores and RAM will not be part of
Then
processing layer.
How we can check the name node capacity, all those things?
Sorry?
Where it includes?
What does it mean?
I mean, so if you want to know
Okay, name node storages are used for different purpose, right? In first disk, okay, we are keeping FSMA edit log. In the second disk, okay, we are using journal edits. Okay, third disk we are using keeper data. So no. So I am using this disk for different purposes. They are not part of SDFS. SDFS is this part, this part. Understood? Okay. I'm using name node disks. Okay, for different purpose. Okay. So all this is metadata. I'm using name node disk for storing different services metadata. Correct or not?
Yes.
Okay. But I'm using data node disk for storing different files blocks, different file blocks. Yes or no? Okay. In the same way, okay. Now, okay, if you understand this one, okay, where these services will be running. Okay, wherever master services are, okay, master services from, okay, or otherwise, okay, I'll put in a different way. Okay, all master services in the cluster run together in a same machine. All worker services will run together in a worker nodes. Okay, it means, okay, all these days, okay, what we are seeing here, all these days, what we are seeing, okay. Okay, you see here, all these days, okay, what we are seeing here. This is what we are seeing, right? Yes or no?
Yes, sir.
This is what we are seeing, okay? So here, these are the zookeepers, okay? Okay, we will take other way, in real time way. This is the real time way, right? Okay, so here, in real time, what we'll have separate services for masters. Okay, yes or no? Okay, these are the worker services. Okay, worker services. Okay, these are the supporting service. Okay, for storage layer. SL means, okay, storage layer. Supporting service for storage layer. Supporting service for storage layer. Master service for storage layer. Worker service for storage layer. Understood? Till now you understood, right?
Yes, sir.
Huh? Okay. So now what will happen? What will happen? Okay. So here, okay. Now up to you. How many RMs you want, you can use those many RMs. Understood? Understood, sir?
Yes, sir.
Worker service for processing layer.
So Venkat, for 4 name nodes, there can be 2 resource managers, but for all
Okay,
data
I'll
nodes,
tell you.
one-
I'll tell you, sir. I'll tell you that also. Okay, so you can have number of name nodes equal to, you can make number of RMs, sir. Okay. Number of data nodes equal to number of
Okay.
node managers. Is it fine now? Huh?
Yes, sir.
yes, sir.
Is it fine now? Okay. Wherever master services are running, storage layer master services are running on the same machine, okay, master service, processing layer master services will be running. Wherever it's okay, processing layer worker services are running. So here in a cluster, okay, all master services will run in master nodes, all worker services will run in worker nodes. Understood, guys? Understood or any question?
Yes, sir. That's what. If we want to know the total storage capacity by simply or by opening the name node, you can see the how many data.
Name node UI. If you open name node UI, okay,
Yes,
you can see the
how
overall
many data nodes are
capacity.
yes, sir. So
Overall capacity, number of data nodes and all. Yes or no?
yes, sir.
If you open name node UI, you will understand, okay, storage layer capacities.
Yes, sir.
Yes or no? So this all together, okay, comes under storage layer.
Yes, sir.
Yes or no?
Yes, sir.
It all comes together under storage layer. Okay.
Yes, sir.
So if I open, okay, in the same way RM resource manager UI, I can see total cost, total RAM, okay, how many node managed information, everything I can see. Like how I am seeing overall capacity. Okay, if I open resource manager UI, I can see overall capacity, processing capacity.
RM will show the only name nodes total capacity.
Not name nodes, but node manager's capacity. Node manager.
Resource manager, I'm asking.
Resource manager will show node manager capacity. Name node will show data
all
nodes
name
capacity.
node. All name nodes.
Name node will show all data node storage capacities. Yes or no?
Yes.
Resource manager will show all node managers processing capacities.
Okay.
Understood?
Yes, sir. That's what, sir. So likewise, how will you get the how many name nodes are running? How will you check the how many name nodes are running in a cluster?
How many name nodes are running in a cluster? You want to check that.
Yes, sir.
Okay. So you have a cluster command, right? Okay. So at this moment, okay, you have only cluster commands, sir. Okay. But in future, I will explain. Okay. In future, okay, when you see the UI, okay, you will understand. Okay. So you can use only this cluster command. Okay. Now you see name node. One name node, second name node, third name node, and fourth name node. Okay. So you don't have any screen to tell that, okay, how many name nodes you have in your cluster.
That means there is no UM mode to see the name nodes
It
already.
is not a UI mode to see how many name nodes you have.
Okay.
Okay, but if you go to name node UI, any name node UI, you can see how many data nodes.
Data nodes. Yes, yes.
Yes or no? Understood?
Yes, sir.
Okay, so if you go to name node, you can see how many data nodes we have. Okay, in the same way, if you go to resource manager, you can see how many resource managers we have. But we don't have any option to know how many name nodes we have and how many data nodes we have. Or do we have anything? I don't think we have. I don't think we have anything. Yeah, there is no way to identify how many name nodes we have. Okay, only option is that okay, to check in the configuration. In the configuration, you can see. Okay, so under my cluster, we can pick. Okay, so name nodes dot my cluster. You can see. Okay, this is the only option, sir. This is the only option you can see. HA dot name nodes. If you see how many name nodes you have, you can see. Understood?
Yes.
Okay, only the configuration is the option in Apache Code.
Okay.
Clear? Or any questions?
Sir, name node is not a part of HDFS, right, sir? As you said.
Sir, what is the question?
I understand, sir. Understand, sir. But what I'm trying to ask you.
Name node storage is not part of HDFS, sir.
Okay.
Sir, okay, see, suppose, okay, let us take this scenario. So, name node is having, okay, 500 GB, sir, storage, hard disk.
Yes, sir.
Okay. So, data node 1 is having 500 GB. Okay. Data node 2 is having 500 GB. Data node 3 is having 500 GB. Okay. Now tell me, what is total HDFS?
All data nodes.
1500.
Huh?
1500.
Okay. This is HDFS, sir. Understood? 300 GB. Okay. So what about this 500 GB? This is used to store the metadata files. This is the capacity of HDFS. This is the capacity of HDFS. Okay. Now, if I put here, what is HDFS? Now, tell me. This is the capacity. Okay. In the same way, okay, RM is having, okay, this is RM, NM1. This is having 10 cores, okay, and okay, 32 GB RAM. Okay, in this capacity. Okay, and this is having, okay. Now what is, okay, overall processing layer? Processing layer. This is overall processing layer. Okay, RM resources will not be part of processing layer. Node managed resources will not be part of storage layer. Understood? Sir?
Yes, sir.
So all are on the same cluster, right?
The same cluster, but all are in the same cluster. Yes, this is Hadoop cluster. So all together is called as a Hadoop cluster. When I say Hadoop cluster, it is a combination of storage, large scale storage plus large scale processing. All together we call it as a Hadoop cluster. When I say Hadoop cluster, you have understood. It's a combination of large scale storage plus large scale processing. That is called as Hadoop cluster. Got it, sir, now. What is logical storage and what is logical processing?
Yes, sir. So just one quick question. So even in the future as well, whatever main work we have, the main activity we have, that will be limited to the HDFS file system. So that's the reason why we have this processing layer only defined towards the data nodes.
Sorry, sir. Can you come back?
So the main work or whatever activity related we will have in the future is going to be limited towards the HDFS file system.
Why, sir?
So
Why? Sir, okay, if
so
you
we-
want to store the data, you will store in the logical storage.
yeah, yeah.
Okay. If you want to store the data, let's say you have employee data, you have 10,000 employees data. Okay, where you will store the 10,000 employees data in the storage layer. Okay,
Yep.
but in the 10,000 employees data, you want to know who are the employees. Okay, taking more than 1 lakh rupees salary. Okay, okay, you will use this logical processing layer to get that information.
Yeah. So it is
Store
always
10,000.
so it is always surrounded by the HDFS file system itself.
Of course, yes. Okay, all the data will be here, and your processing will be done on this storage.
Okay, so that is the reason why the whatever processing we have. So even if if we are limited with the processing, then we will be adding the one more node, and then that gets more processing. So in the future there will be no process, or let's say there will be no major activity in the name node where we need more processing power, right? I'm just curious about it.
Name node, yes, no more processing power is not required.
So right now we only have that metadata related work. So even in the future as well, we will not have
future
any
also. Yes.
Okay.
So okay, see, even if I introduce logical processing, name node basically will be doing name node work. That's it.
Okay. Yeah.
Yes or no? Because of processing, will name node change its characteristics?
No.
Or its responsibilities? No. Got it.
Yeah.
Yeah. Okay. So I hope you understood what is Hadoop cluster now. Hadoop cluster is a combination of storage layer services and processing layer services. Okay, this is Hadoop cluster. Got it.
So processing means like only RAM, core, that information.
Yes, RAM and core. That's it. Processing means RAM and core. Okay, storage means disk. Understood.
Sir, sir, when you are installing the Hadoop, if you are run the yarn command, you have the yarn services. So the resource manager, node manager will start the services.
Yes, sir. Okay, yes, sir. If I start yarn, it will start resource manager and node manager services on respective machines.
Yes, sir. Likewise, if you start the AFS, the storage services, it will
start name node and data nodes.
Data node and secondary node as well. So
of course, yes, if it is there, yes.
In that case, it should be comes under HDFS, name node also.
Sir, all this together comes under HDFS. Sir. This is HDFS. This is yarn.
Yes. Understood. The only thing is that storage is not including logical storage.
Okay. Wait. Yes, too much thinking is creating too many problems, sir. Hadoop cluster means Hadoop cluster equal to what is Hadoop cluster? HDFS plus yarn. Name of the storage layer, sir? What is the name of storage layer?
HDFS.
What is the processing layer?
Yeah.
Okay. But for this HDFS, when I say HDFS, HDFS contains master services and worker services. Yes or no? Yes or no, sir? When I say HDFS, okay? HDFS means name node plus data nodes. Yes or no? What is HDFS? HFS is made up of name nodes and data nodes. Yes or no? CAN is made up of? What is the question now?
Okay, sir. I think that was a confusion. I was assuming HDFS is only specific to the logical storage. So HDFS ante name nodes and data nodes.
Altogether equal to HDFS.
Okay.
Understood.
Sir, the node manager purpose and sir, actually.
Tomorrow I'll explain, sir. What is the purpose of resource management manager? I'll explain tomorrow. Okay. Sir, when I say HDFS,
data nodes ki node manager ki ana link up unta sir.
No.
Ante node manager ఏమన్నా only data nodes ని maintain process
no. Sir, okay, see, very simple, sir. Okay, see, if you want to store the data, you will use storage. Yes or no? You will use storage. Storage will be handled by data nodes. It means, okay, if you want to store the data nodes will come into picture. If you want to process the data, node managers will come into picture. Got it? Okay. Yes. Okay. So we'll stop it here and we'll continue tomorrow. Okay.
Okay, sir.
Okay, sir. Thank you.